Hello class, this is a video tutorial on the proof of the distance formula, this one here. So let's take a look at the horizontal distance between these 2 points. Let's just say that these are 3, 2, and this one is 5, 2. Okay, we know that they're along the same height. As a result, we can figure out how far apart they are. We can just count 2 spaces. From 3 to 5 is 2 spaces. But I want you to think of it this way. How far is it from 0 here? So I'm going to mark it from 0 to this point here. If you take a look, that there is actually there is 5 units, because if that's 5, this length is 5. Similarly, how far is it from 0 to 3? So from 0 to 3, well, isn't that 3 units away? Well, if that's 3 and that's 5, this one here must be 2 units. I know it doesn't look to scale, but that doesn't matter. So we can find that by saying that's 5 minus 2, 3 is equal to 2. And then the exact same thing with this. So let's say that this here is, let's say we have this as 4, 1, and this one here as 4, 5. We can find the distance between them by just looking at the y coordinates, and you can see that there are 4 spaces in between them. Okay, or you can think of it as, how far is it from 0, height of 0, to a height of 5? Well, isn't that height or that length 5 units? Same thing with from 0 to 1. That one there. Isn't that 1 unit? Which gives us that this one here is 4. Or we can say 5 minus 1 is 4. So we can say 5 take away 1 is equal to 4. With that in mind, we can apply this with any coordinates. Let's just say that this one here is x1, and this one here is 5, because it has to be the same height. And we'll make this one x2 and also 5. So as you can see, the 5s don't really matter. It's these ones here. So how far is it from here, from 0 to this point here, x2? Remember, x2 can be a number. Wouldn't that be x2 units away? So whatever number it is, it's x2 units. And same from 0 to x1. That one there, that's x1. Wouldn't this distance now from here to here, wouldn't that be x2 minus x1? Kind of like what we did here. This distance from here to here is 5, because it's from 0 to 5. Take away the 3, which is equal to 2. Same thing with this one. Let's say that the x coordinates here now is 4, and this one is y1. And this one here is also 4, and this is y2. Same thing. How far is it from, the 4s don't matter. We're focusing solely on the y coordinates. So how far is it from 0 to y2? So how far is that distance there? Wouldn't that be y2 distance. So whatever number that is, it's y2. Same thing from 0 to this point here of y1. Isn't that y1 length? So won't that give us from here to here, isn't that y2, that length, subtracted by y1? So that there is actually y2 minus y1. Same thing, let's like what we did here. Isn't this length here, isn't this 5, take away 1, give us 4. And that is what we use. Actually, this idea is what we use to find this diagonal length. So let's take a look here. What we actually do is we draw a triangle. So let's drop the x coordinate here, like this. And then we complete this triangle like so. It actually constructs a right angled triangle. You can see it right there. So let's make the coordinates for this one x1 and y1. Let's make the coordinates for this one x2 and y2. So we want to calculate the length of this one here. Let's label that C. Okay, and let's label this one A. And then let's label this one B. That length there, that's B. But we already know the distance of this one here. We know that C squared is equal to A squared plus B squared. But we don't want the length of C squared. So what we do is we take C and we square root both sides, which gives us A squared plus B squared, all square roots. But now take a look. What is the length of A? Can you see that? Isn't that y2? And isn't this point here y1? So isn't this length here y2 take away y1? So the length of A is actually y2 minus y1. Same thing with B. Isn't B, isn't that x2 here? So from 0 to x2, isn't that x2? Take away x1. So B is actually x2 take away x1. Now if you take a look, A is equal to this and B is equal to this. But we have this formula here already, so we'll just substitute those values in. We get A is actually y2 and y1. So we'll take a look. We have here A has now become y2 minus y1 squared. The plus is still here. And B is x2 take away x1 squared. And we can just actually swap these two around just so we get our formula. x2 minus x1 squared plus y2 minus y1 squared. Okay, now just to prove our point here, let's take a look at these coordinates. Let's just make this one, for example. Let's make that 1, 2. And let's make this one, I don't know, 5, 4, 5, 5. Now take a look here. If we draw our little triangle, we can get a right angle triangle going on here. If you really want to figure out what this coordinate is, it's got the same height as this one and the same x as this one. So it's going to be 5, and this one is 2. We can calculate the length of this, because from 2 to 5 is 3. Or we can say 5 take away 2 is 3, which is y2 minus y1. And the length from 1 to 5 is 4, or 5 take away 1. So can you see how this length was actually 5 take away 2, or it was y2 take away y1, because y1 is here, which is the same as y1 here. This one is y2, so y2 take away y1 gives me 3. And this one here, it has x2 5 take away x1, which is 1. That's x1. So that is actually 5 take away 1, which is 4. So we can get the distance, which is equal to y2, which is 5 take away y1, which is 2 all squared, plus x2, which is 5 take away x1, which is all squared, square root everything, which will give us 3 squared plus 4 squared, square root, which gives me 9 plus 16, square roots of 25. D is a distance of 5 units. So that there's the proof of the distance formula.